Okay, we are on the sixth and final page of this review packet. So number 67 says a rocket is launched into the air. The height in feet of the rocket above the ground is given by h of t, which is equal to negative 4.9 t squared plus 220 t, where t represents the time in seconds after the launch. And it has three questions. How long is the rocket in the air? When is the rocket at the highest point? And how high is the rocket at the highest point? Well, one of the best ways to deal with this problem is to graph it with a graphing calculator. So let's get our graphing calculator in here and graph this problem. Whoops. Okay, so let's start by turning on the graphing calculator, going to y equals, clear anything that's already in there, and put it in that initial equation, which is negative 4.9. And I know it says t, but you can put x squared plus 220 t, or x. And now let's graph this equation. Now an initial graph might not turn out as nice as you might want it, so you don't see anything there. So let's try to zoom. Sometimes there's a nice thing, zoom stat, zoom to fit. Let's see if it fits graph in there for us. There it goes. Fits it in there. So you can see this quadratic is going up like that. But I don't like that. So let's change our window. Click on window right here. Zoom this up a little bit. Okay, so click on window and see how x min is 0. Well, it doesn't, if t, which is your x's time, doesn't make sense to have a negative time, so let's make that 0. Let's start at time 0. And our x max is 10 seconds. Well, if a rocket's launched in the air, I would say rocket could be in the air for more than 10 seconds. I don't know, what do you think? How about 60 seconds? Maybe even longer. And if it's launched in the air above the ground, it can't be below the ground. That's what your y represents, so y would probably start at 0. Let's just say, I don't know how high it goes, maybe 5,000 feet. We're just guessing to see what the graph looks like. Okay, so there's our graph of it. Oh, and there we go. So we have a rocket. It's launched at time 0 up in the air. It gets up to a maximum height right there at this time. And it comes back down at this point. Lands on the ground and explodes. So let's start answering some of these questions. The first question is, how long is the rocket in the air? Well, to answer that question, we just need to use our little trace function. Here we got a tracer. And we just got to see how far to the right this is in the air. When does x become 0? Or, sorry, y becomes 0 over here. And that will tell us how long it's been in the air. So if we keep on going, we're trying to get to y to be 0. Here it's somewhere between there and there. So it looks like between 44 and 45 seconds. I would say 45 seconds in the air. So 45 seconds. And pretty much what I got is, how I got that is, if you look at this, this is the height, y represents the height of this rocket, this x represents the time it's been in the air, and when the height goes from kind of a positive to a negative, right, like that, we went from 44 to 45 seconds, so that would mean it would be about 45 seconds is how long it was in the air. Okay, the next question is, when is the rocket at the highest point? Well, let's take a look. If we get our tracer, we want to work our way up to that highest point right there, and then we'll figure out what our x value is at that point. So let's get it up there. And it's, looks like it's at the highest point around, I don't know, what do you guys say, 23 seconds? Yeah, I'd say about 23 seconds. Maybe 22.5, 23 seconds. 22.5 or 23, somewhere in there, 23 seconds. And how high is the rocket at the highest point? Well, at 22.3 seconds, or 22.5 seconds, it looks like it's really close to 2,400. It's getting higher than that. 2,470, maybe. 2,470 feet. This is the height at the peak, so 2,470. 2,470 feet. So that's how you can use your graphing calculator to solve a problem just like this. And actually, I think 68 has a very similar problem. Take a look at 68. A rescue helicopter hovering at 68 feet above the boat in distress drops a lift raft. The height in feet of the raft above the water can be modeled by this function h of t is equal to negative 16t squared plus 68, where t is the time in seconds after it is dropped. The two questions is, how long does it take to hit the water, and how high will it be after 1.5 seconds? Well, again, let's take this and put this equation into our graphing calculator. So we got y equals negative 16 x, which is the same as t, plus 68, and graph it. And let's see what we got. Oh, so it looks like nothing there, but if you see right here, there's something weird going on there. So let's do a zoom in on that little spot over there. Okay. Sorry guys, this is taking so long. Okay, we're going to zoom in down in here. There we go. So look at that, so something happened. Remember, okay, so our window, let's set our window. Again, time, it's got to start at 0. Looks like 8 seconds is enough. Let's make that 5 seconds. The min doesn't make sense. It won't be going below the water level, the ground. So, and this height, well, we started out at a height of 68 feet, so it doesn't make sense to go any higher than that. You're dropping something, right? So this should be good to go. Let's graph this. Oh, and there we go. So we got to drop that 68 feet. It's falling, and it hits the water at that point. Let's bring our trace, and we can answer some of these questions. First question, how long does it take to hit the water? Well, let's just see. Let's trace. There's my trace. There it is. So when will this y be at a height of 0? About, let's get it there. Looks like it's between 2.02 and 2.07. How about 2.05 seconds? Something like that. So 2.05 seconds. That's a 0, not a 6. And then how high will it be after 1.5 seconds? So let's just kind of work our way up to 1.5. It looks like it's going to be about 30 feet in the air. About 30 feet in the air. Now, if you need to be more precise on this graphing calculator, you would zoom in on this just to make sure. But I'm just guesstimating right now. Looking at this, at about 1.5 seconds, you're about 30 feet in the air when you go between this one and this one. Okay. Okay, let's move on to number 69. Number 69 says use the quadratic formula to solve these problems. Okay, so use the quadratic formula to solve each equation. Give the exact solution. Well, remember our quadratic formula is x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And what I like to do is I like to try to figure out what this is on the side and then plug everything else in. Now to do that though, I got to figure out what my a, b, and c are. Let's take a look at this. Well, sadly it's not in our standard form. Let's get it in standard form. Let's get this equal to 0. Then we can figure out where a, b, and c are. Let's add 5x, add 2. So I have x squared plus 5x plus 2 equals 0. Now I know my a is equal to 1 from there, my b is equal to 5 from there, and my c is equal to 2. Okay, so we're going to take this and plug it into this. Well, plug all of this in here, into this formula, and first start with this. So let's get this b squared. So I got b squared, which is 5 squared minus 4 times my a, which is 1, times my c, which is 2. And we're going to square root that sucker. 5 squared is 25. 4 times 2 is 8. So 25 minus 8, what are we talking? 17. So I got the square root of 17. That's what that is equal to. So this thing right here is equal to the square root of 17, like that. So let's rewrite this. We have x equals the opposite of b, which is negative 5, plus or minus the square root of 17 all over 2 times a. 2 times a is 1. So can we simplify this down at all? Well, 17 is a prime number, so you can't really remove that from the square root. And there's nothing in front of it to cancel off with this 2 or anything like that. So our answer really is x equals negative 5 plus or minus square root of 17 all over 2. There's your answer. Let's do the same thing for number part B of this. We got 2, 3, and 7. So we know our A is equal to 2, our B is equal to 3, and our C is equal to negative 7. Okay. Let's first by finding this, the determinant right there. Or sorry, discriminant. So we'll start by b squared minus 4ac. So we've got 3 squared minus 4 times my a times my c, which is -7. I'll square root that. So we got 9 minus 4 times 2 is 8 and 7. So we got, since it's 11 o'clock, I'm going to make sure I'm not doing this wrong. 56. So 9 minus -56, so that's plus 56. 6. 9 plus 56 would be 65. So we get the square root of 65. That's what our discriminant is. Okay. Let's put it all together into one thing. Well, actually, can we simplify this down? 65. What does that break out into? 65 breaks into 5 and 13. Yep, I think that's as good as it gets. Can't break. Yeah. Okay. So this right here turns into x equals negative b, or the opposite of b, -3, plus or minus the square root of our discriminant that we found, which is square root of 65 all over 2a, or a is 2, so that's 4. And there's your answer. Oh, and I'll just box this answer up here. Okay. Moving on to number 70. 70 says, find the zeros of the equation. Well, I look at this and I'm tempted to factor it, but I tell myself, there's maybe some weird stuff going on. Maybe I should, instead of doing the slide and factor, let's use the quadratic formula to factor this. So again, let's figure out my a, my b, my c, which is 9, -15, and -14. So let's start by finding my discriminant. So we got -15 squared minus 4 times 9 times -14. Now, make sure you use parentheses here or everything could be messed up. Let's put this in our calculator. -15 squared minus 4 times 9 times -14. 729. Okay. So we got x equals, what's the square root of 729? Oh, square root of 729 is 27. That's nice. Nice clean number. Okay, so x equals -b, so 15, plus or minus the square root of 729, the square root of 729, which is equal to 27. So this is 27, all over 2 times a over 18. So we're going to break this up into 2 ways. We're going to do the plus and then do the minus. Let's do the plus up here. So we've got 15 plus 27 over 18. That's doing the plus. 15 plus 27 is 30, 40, 42. 42 divided by 18. So we got 2 and 1/3 for this. Okay, that's one solution. And we're going to do the minus. So 15 minus 27 all over 18. 15 minus 27 is -12 over 18. 12 over 18 is -2/3. So our 2 solutions are -2/3 and 2 and 1/3. Those are our 2 solutions for this. Okay, moving on to number 71. 71 says solve the equation by factoring. Okay, so this one says you can factor. Let's do it. Let's get it equal to 0 first. So let's add 17x, add 5, so we got 12x squared plus 17x plus 5 equals 0. Now my first step is, because this is a 12, or there's a number in front of this x squared, we're going to do the slide unless we can factor something out and it doesn't look like it. So we got 12 times 5. So what I get now is x squared plus 17x plus 5 times 12 is 60, equal to 0. Okay. So we're going to ask ourselves, what times what is 17? That add together would be 60. Well, we'll start with 1 and 60, that doesn't do it. 2 and 30 makes 60, but that doesn't make 17. 3 and 20. Oh, 3 and 20. 3 times 20 is 60. 3 but it's negative. Shoot, that doesn't work then. Okay, so because 3 and 20 does make 60, and if you subtract it, you get that, but our issue is this is a positive, and this is both a positive, so that doesn't work out. 4 and 60, 65 by 4, yeah, 4 and 15, that gets you 19. So that doesn't do it. 5 and 12. Looks like this is it, 5 times 12. 5 times 12 is 60, 5 plus 12 is 17. So we're going to rewrite this as x plus 5 from here, and x plus 12 from here. That's equal to 0, but don't forget about this 12. Remember how we slid the 12 over? That means we have to deal with that 12 right now, so we're going to divide both of these by 12. Okay, now we got to simplify this. 5 and 12, can you simplify that? Nope, so you're going to do x plus 5 over 12. 12 divided by 12, can you simplify that? Yeah, you can. X plus 1. And that's equal to 0. So now you got to ask yourself, what are the solutions to this? Well, what do we have to put in here to make this equal to 0? Because if we make this equal to 0, 0 times this will make the whole thing equal to 0. Well, in this situation, what plus 5 halves is equal to 0? Well, negative 5 halves plus 5 halves is equal to 0. So one solution is negative 5 halves. And what do you have to put into this to make this 0? Well, what plus 1 is 0? Well, negative 1 plus 1 is 0. So we got negative 1 is our other solution. That's how you do 71. Did you get all that on there? Yeah. Okay, going up to 72, we're going to be starting to work with imaginary numbers, adding, subtracting, multiplying, dividing, all that good stuff. So let's start with this one, 72. It says add these. Well, really what you do is treat them like the like terms. Treat the i's like the x's in a little bit. We got to bring this and this together. Well, what's negative 4 plus 6? And then we have to bring this and this together. So plus 2i minus 3i. Well, negative 4 plus 6, well, that's negative or positive 2. And 2i minus 3i is negative I. So my solution is 2 minus i. Right there. Okay. Now, this next one wants us to subtract. Now, subtraction, you always want to take care of that subtraction. We'll make it a plus, but remember, this has to be negative or the opposite of that, and that has to be opposite. And now we treat it the same way. We got the 2 and the negative 5. We're adding those together. So we've got 2 plus negative 5. And we got the 5i plus the negative 3i. So plus 5i plus negative 3i. What's 2 plus 5i? That's 3i, negative 3, sorry. And what's 5i minus 3i? That is 2i. So your solution is right there. Okay. Moving on to 74. We need to simplify this. Again, we're subtracting, so we're going to make that a plus, and that becomes the opposite. That becomes the opposite. So we bring that and that together. So we got 7 plus 6. And bring this and this together. So we got plus 7i plus 2i. 7 plus 6 is 13, plus 7 plus 2 is 9i. And there's your solution. Here we got to simplify this. This gets a little bit more complicated. We're going to go back to the box method that we use for multiplying binomials. Okay? Remember, when we're dealing with i's, I put this other little box down here to help us deal with the I squared. Now, 2 plus I, we'll put that there. And then we got 3 and I right here. So we got 3 times 2 is 6. 2 times I is 2i. 3 times I is 3i. And here we have I times I, which is I squared. But we know that I squared is equal to what? It's equal to negative 1. So this box right here is really negative 1. Okay. So let's combine like terms now. What's 6 and negative 1? Well, 6 and negative 1 makes 5. And what's 2i and 3i? That's 5i. So your answer is 5 plus 5i. Let's try it again over here on this one. This is again multiplying these. I'll make my box a little bit bigger over here. Okay, move that up. So, got another little extra box right there. So I'll do 3, negative 2i, negative 7, negative 3i. Negative 7 times 3 is negative 21. Negative 7 times negative 2i is 14i. Negative 3i times 3i is negative 9i. and negative 3i times negative 2i, that is 6i squared. But I squared is negative 1, so this is really negative 6. Okay, so let's bring these terms together. Negative 21 and 6, that gives us negative 27. And negative 9i and 14i, when you add those two together, you get 5i. Oh, so plus 5i. There's your solution, negative 27 plus 5i. Okay, moving up to number 77. It says express the following in a plus bi form. Well, this one is very similar to these two above, right here. Really what we have, this is really just 4 plus 2i times 4 plus 2i. So let's just make a box like before. Put a little special box down here. So we got 4, 2i, 4, 2i. 4 times 4 is 16, 4 times 2i is 8i, 4 times 2i is 8i, and 2, and that's 4i squared. But I squared is negative 1, so we've got negative 1 times 4, which is negative 4. Bring together like terms, 16 and negative 4 gives us 12, 8 and 8i gives us 16i. There you go. That's for number 77. And finally, the last problem. It says solve the equation. Write your answer in simplified radical form. Okay, right there, because it says simplified radical form, I know that I cannot factor this because there's going to be a radical, which means I need to use the quadratic formula, which is x equals negative b plus or minus the square root b squared minus 4ac. That is all over 2a. Okay, so let's figure out what's my a, what's my b, and c. Well, a is 1, b is 3, and c is 5. First, I'm going to focus on discriminant right here. So I got square root of 3 squared minus 4 times my a, which is 1, times my c, which is 5. So I got square root of 9 minus 20. So I have the square root of 9 minus 20 is negative 11. Holy cow, 9 minus 20. Negative 11. We got the square root of negative, everybody. That's going to mess things up. You can't do the square root of negative, right? What does this simplify down to? Well, the square root of negative 11 is really equal to the square root of negative 1 times 11. This is really equal to the square root of negative 1 times the square root of 11. Well, we know the square root of negative 1 is defined as I, so really we have I square root of 11. That's what we're going to put up for our discriminant here. Let's rewrite this as x equals, we've got negative b, that's negative 3, plus or minus, this turned out to be I squared 11. So we got I square root of 11 all over 2 times a, well, that's just 2. And there is your solution. So that is the last problem on page 6 of this review packet.